Hey everyone, this is the Gravity Engraving channel, all about laser machines and markers. My name's Igor. Igor, for those who haven't heard yet. Well, damn, plenty of you haven't heard that my name is Igor. My name's Igor. So, here's a simple example. When you have 3, 4, 5, or 6 machines and specific tasks to do, you start working and think, man, which one should I use? And that's exactly the question we're answering now. Choosing the equipment for 3D engraving, 2D engraving, basically what I'll use to carve through all these materials. I'll tell you right now, before I definitely would have chosen the JPT50LP, but I don't have it in my workshop today. I have other machines. Let's take a quick look at them, see what they can do, their pros and cons, their strengths and weaknesses, and what we can make with them. Which machine will I pick for 3D engraving today? Today, we're doing 3D engraving using a height map, and I only have 3 of those machines available. Only, well, one of them is just too expensive for these kinds of tasks. There's also the option to do 2D on one machine very well, but I don't like doing it on the other one. So let's see what we'll run on each. Today we'll be doing titanium processing. Again, I'll briefly show the final results, the machine used, how I did it, and where I started. We'll probably do the 2D on the ESCAD 3.0 JPT60M7. That's what I'm thinking. For the 3D, we'll see. I'll either use the Xtool F2 Ultra, keeping you in suspense there, right? Yeah. Or there's the JPT50M8. Let's go see what we actually have in the workshop at least. Let's start with a quick look at the JPT50M8. It's a good machine for 2D engraving, marking, and engraving tags. You know, all sorts of custom orders. No glass organics here. So engraving with 174 by 174 lenses or 100 by 100 if necessary. Sometimes I use a 70 by 70 lens and very rarely a 220 by 220 lens. Keyboard marking at 70 by 70 or some micro engraving, which is also very rarely needed. The 100 by 100 lens is for most jobs, but I'm so lazy that I just leave the 174 by 174 lens in. 3D is only done with Lightburn using height maps. That's it. I don't use it for anything else. I mostly work with ESCAD 2.0. I do all the tasks on this machine, specifically those set up for, again, ESCAD 2.0. Moving on, the Xtool F2 Ultra. It's an awesome little machine. So for 3D, I can't say how good or relevant it'll be here. There are minimal settings, so it's easy to start. The quality is unpredictable because I haven't worked with this machine much. But the plus side is you set it up, tune it, start it, and forget it. Then you come back in 3 or 4 hours and get the finished result. 3D, again, using a height map in the software, so it seems as simple as possible. There are some nuances, which I'll explain, and I might actually finish filming some training material for this specific machine. And you'll have the chance to buy it and go through it step by step. 1, 2, 3. The actual training material for this equipment, I'll also talk about the hardware itself. Plus, we'll cover layout preparation or working with AI on these machines. So, moving on. The JPT60M7 machine. Its strengths are that it's built with a dynamic electric scanner. 3D work basically, it runs on ESCAD 3.0, works with STL files, and has an unlimited buffer, meaning RAM, so however much we have on the laptop, that's what we use here. Other pros? Color engraving, lens expansion, machine dynamics, and stability. But there are cons too. 3D processing is limited to STL files only. Height maps aren't supported here. Well, or swap the controller for another one and basically mess around with it. Again, I'll say it, I really like this machine. I don't really like ESCAD 3.0. And here, we'll most likely be doing strictly 2D. I'll leave the 3D to this machine for experimentation, nothing more. I'm not sure about getting a 100% high quality result in the end, because to work specifically with titanium, the key is picking the right frequency range, Q-pulse control, and accordingly the hatch density. That will also be an important factor. Here, unfortunately, there's a limit on the hatch density. See, we can't do more than 300 lines per centimeter, which is 0.03 millimeters. That's very little. To work with titanium, we need to use either 100th or, say, 15 thousandths, or, well, at the very least 200ths of a millimeter. So I'll give it preference today, but considering how it engraves, it's unlikely. Plus, again, a small detail, in this case, on this table, there are 3 machines, and we only have one exhaust hood here. Whether it works or not, who knows. And let's move to the third machine, which was also just set up, started, and prepared. Basically, here we have water cooling, a coaxial control output, power, a chiller control cord, meaning on and off, and direct control via the COM port with a service connector for this source's power and connector output. I'm not closing the unit, we'll be testing it soon. Specifically for heating and warm-up, this machine should perform 3D engravings really well using the LaserBoss software via a height map. But there's a very big catch. The machine is only 20 watts. I haven't put it through its paces in those areas yet. Whether it's worth running it for 3D, I don't know. If it's cost effective or not, I don't know either, because the chiller will be running, the expensive source will be running, plus a special separate computer will be dedicated to these tasks. How relevant that'll be, I can't say. Whether I want to do it or not, I don't know yet either, but it's a big question mark. Moving on to the layouts. Maybe I'll start this machine today and show the final result. It's actually quite simple here. Here we have Xtool Studio. Loading, the project is loading, click New. In the new one, we'll load either by dragging and dropping. Again, the Xtool F2 Ultra connected automatically, once again offering fixed some known bugs. Some bugs we know about. Yeah, fixed. Remind me in 3 days. We won't update now. Our time is precious. Today, unfortunately, well, our task is to load the project. I'll do it with this simple drag and drop method. Okay, don't show this. For 24 hours, the image is larger than the canvas is scaled down. Let's scale it down. There, we're gonna have this 3D format engraving, and I know for a fact that the width of these sides, the proportions, is exactly 24 millimeters. So we'll set the width to 24 millimeters. By the way, I'm not trying to criticize the Xtool guys, but overall, yeah, this centering feature is in much higher demand than any other functions in this workspace because the object shifts to the top left corner after you resize it. So you always have to use the center. Centering's a priority task, so maybe it's better to put it at the top. Just a little tip from afar. I know the Xtool team based in Moscow. They follow me, watch all my videos, they fix things here and there. Sometimes they help out and explain things. So from the standpoint of, let's say, customer service, that's how they do it. They're great in that regard. I don't know how they have the nerves for it or what sedatives they take because the equipment customers Xtool gets, they don't get to choose. Whoever comes to them, that's who they have. I can choose my clients, which is a huge plus. But honestly, even with them, I get stressed out. Anyway, we need to set the focal length. The machine connected automatically. Click on the ruler in the top right. Again, unfortunately, Xtool has made me lazy in this regard and my brain is rotten a bit because all I have to do is click the ruler button and then just align my engraving based on the image and start the engraving process. So you see, right, how this idiotic level of simplicity, it leads to degradation. It's both good and bad. Yeah, I know, I'm complaining about something minor that I shouldn't be. Anyway, let's move on. We're doing 3D relief processing. Select relief at the bottom. Next, let's see what we have here. Relief selected. The laser we're using is a MOPA fiber. 256 layers, including the 0 layer. Power. For titanium, there's no point in setting it higher than, let's say, 50%. Speed. To be honest, I want to process it 3000 millimeters per second, but I know the relief won't be very deep. Let's go with 2000 millimeters per second, one pass. For the line, we'll set the maximum value, which is 3000. Engraving angle plus increment. Let's just do, 20 degrees and ignore all the rules and standards. Now, the frequency range will be important here. Honestly, I want to work at around 280 kilohertz. That's a lot, like really a lot. And I want to get the corresponding result. Regarding the Q pulse, I don't remember and I don't know, say, in this source, but I can assume that in similar sources, I'll even check the Q pulse relative to the frequency range on my little machine here. And I'll even tell you. So we're using 200. How much is it, and why do we have an angle? The angle is 280, right? Let's consider that this is version E2. They're more or less the same. 252 kilohertz is 20, and we're using 280, which is 13. Let's set it to 252. 252. Well, go by the values we have so we don't mess up. Lowering the z-axis, that functionality is available here. Now, do we need it here or not? The tag is 2 millimeters. The defocus will be approximately half a millimeter. I don't see the point in it, so we'll uncheck that box. A huge plus. We don't need noise reduction, and we don't need cleaning here either. That's a plus. We've set the auto rotation. I'll record a separate video later. I'll definitely show you. Let's go to process. Additional, processing path, automatic planning. In automatic planning, we'll exclude user definition because there's a certain nuance there. So I recommend everyone do it this way. I'll record some footage separately, I repeat, when we have a bit of time, on something not very important. So you can see how incorrectly it actually handles this part. And that's basically it. Next, we press start. Wait, a question. I have a question. Where did the start button go? Oh, the process was moving to the right. Again, I recommend doing the first test at low power, meaning we'll have the power at 50%. Let's do it at, say, 12% power. If something goes wrong, or if it's positioned unevenly or incorrectly because the camera's at an angle, we'll be able to fix it all. Press process. Also, the processing time's interesting. 1 hour, 28 minutes. Well, surprisingly fast. Now we'll check the quality accordingly. If we don't like it on this machine, we'll switch to another one and do it either on a super expensive machine, or we'll do it on the MOPA GPT-50M8 running Lightburn, but I'll set the density there to something other than 0.03 millimeters or 300 dpi. Well, we'll set the value to 0.01 millimeters. Press start, go over, and test the alignment. If everything aligns, we'll start it up and see the result. Yes, the fan, I took it off, so we confirm and get to work. Let's not disturb the machine while it's working. Basically, everything is fine here so far. As you can see, the 3D effect on titanium will be 100% ready. It'll satisfy me and the client. Definitely. Let's look at something else instead. Today we're starting up the machine. We'll experiment while it warms up. Oh, no, everything's fine. Everything's great. While our chiller is warming up, while it's starting up, we're going to be starting up our equipment here today. Unfortunately, yeah, we have a flash drive. We only have one USB port here, and it's taken up by the mouse. So what's the big problem? Well, we need to download a folder from the flash drive called picosec. It's a really big file. Yeah, like a lumberjack, but it's called picosec. We're loading it onto the computer. Meanwhile, we're tidying up a bit. There. Everything seems fine here. All the cables are connected. We're hooking up the USB Type B. I haven't actually tested it yet, just put it here. I was surprised that at the factory I visited, they didn't have an L-shaped connector like this. Yeah, they told me Miu. Strange, very strange, of course, but oh well. We installed the L-shaped connector and hooked everything up. A quick look at the connections. The control... We'll go through the coaxial connector. There are two more extra ones here for slightly different purposes. I'll get into that a bit later. 24 volt power. The control, again, is directly from the chiller, turning our chiller on and off. And controlling the source itself, specifically the power, connectors, and connection via a separate cable. We'll be connecting separately now, right, through the service connector, through the COM ports. The cooling is already running. The water's flowing through here. We're using distilled water. We added a tiny drop of chlorine and a little bit of pure ethyl alcohol. We didn't add any isopropyl. Our controller is the gray one, connected under the laser boost. We'll work with that too. We'll test it out and see what happens. Wow, that downloaded fast. It took much longer to load from the flash drive. So about picosec, we have a ton of interesting stuff here. We need the pico laser. And there's a lot of useful info here. We go into the release again and install the software to work with our COM port. And let's launch it. Let's look at this engineering marvel. I mean, backlit buttons, how nice. By the way, funny thing, the backlight runs on 220 volts. And voila! Starting the source. Okay, so it started. That's great. That's really nice. Let's go ahead and press the button, and just like that, we launch our program. Damn it, the mouse died at the worst time. Yeah, okay. Everything here is as clear as can be. It's not in our language. Switching to English, and now we're entering the settings. Okay, let's start with the two main problems. First, our computer's outdated. The computer's running Windows 7. It's being phased out, both mentally and physically. Everyone who can. Google is refusing to work on Windows 7, or Windows 7. Actually, all programs are also blocking as much as possible and won't install. And the next situation is, if we try to do something there, like download drivers using Yandex, Yandex starts pestering us with, "Are you a robot or not?" With endless messages, something's jumping, something's installing. Anyway, screw it, let's close this computer. We're working on the modern 10, although they'll probably start blocking that soon too. Let's start the project, and here's the coolest part. Setting up the machine happens pretty quickly. Let me zoom in like this. As a result, we get samples like these. Again, in some places they work like this, and others like that. Well, it's pretty good. This is the side effect. If we take nickel on very, very thin nickel, look closely. We have two engravings here, and both are specific. On one, it's obvious that we have too many polygons, so now we'll lower it a bit and play around with the power. And I can already see that the result is awesome because everything is turning out surprisingly well and the metal isn't warping. Just like that. Cool, I like it. Now, probably the most interesting experiment is the nickel plates. I've already played around with stainless steel a bit, now let's blast the nickel. Everything here is as simple as possible. The plates were provided by one of our subscribers. Oh damn, I hope I don't break it. There. Basically, we're gluing it onto our played and running tests. There will actually be a ton of tests. We're going to test it now. Again, based on the fill density, we'll use all sorts of different power, speed, frequency, and much more. The tests take a hell of a long time. Nickel is a whole other story. The quality will be fire, of course. Even considering that we're using a lens with a working field of 174 by 174, the fan still starts up. I'll also show separately with a thermal imager how our power supplies heat up and whether we still need to run. The separate fan at the bottom, which creates extra vibration, or buy a good expensive fan. Although even odder. Even this fan still creates a slight vibration in this part. No matter how well or perfectly we do everything, vibration will still be created by the water circulation. So how do we eliminate all that so everything is perfectly cool? Who knows? For now, but we'll think of something. In time, let's go test it. Now for the moment of truth. The truth starts for us at about 15 watts. That is from 15% power, and we go higher. 20. It seems okay, but the pattern and the engraving itself looks specific. Yes, it's less noticeable, but pretty good. So 20, yes, 25 is better. There's a certain fill density again where we get a good result on the engraving, the relief. Actually, transitions and much more. Not to mention power levels like 30, 35, 40, 50%. Everything looks great almost everywhere. The engraving happens quickly, we don't need high density here, and we get the corresponding result. So you can work in almost any mode, while our plate remains completely flat, smooth, and without distortions. Of course, from different angles, it looks optimally, at a power level at 20 to 25%. But overall, well, the brightest and most saturated ones are over 30% power. But again, I'll say it once more. If we rotate it like this, we get almost all of our fills, processed to the fullest from start to finish. Yeah, not every angle works for. Though yeah, even polarization doesn't matter here, because it looks cool as it is. Well, not bad. I'd even say it's good. Yeah, guys, here's 3D engraving for you. That moment when you think you've achieved the best result on the best machines, there's an even better option on an expensive machine. Of course, yeah, it's very expensive, but if we're talking about some super high quality 3D engraving, I now know where to get it done. To get a mega result. As for surface roughness, it's practically non-existent. So look at these edges and corners here. I rubbed it a bit with GOI paste, just a tiny bit, because I had to remove this little black soot that formed here. But the quality, I'll say it again, for 3D, I'm totally blown away. Yeah, that's a result, an expensive result. We won't be doing this, it's very expensive, I'm telling you straight up. But overall, it's just fire. When I saw it, my knees even started shaking a little. Seriously, it's a thrill when you get a decent result. So for the machine, this is, let's say, the third application that worked out. It works effectively with quality and it's cool. Moving on, there's one more idea. We'll do it now too. Let's wrap up our final results. The hassle is that even today, working here in the office, yeah, today is my day. The first day I've been in my own office. Still, even in this situation, they killed our power, it seems. Although that's extremely rare. The whole district was cut off. I don't know why. I'm not whining at all right now. I'm not saying everything is bad or sad. So today, I had a chance to run the machine to test it. Yeah, we ran some 3D there. It turned out awesome. No questions at all. The quality's super. I think Sergey from Novosibirsk wrote to me, like, how did you get it like that? Did you polish it? No, I didn't polish it. It's specifically 3D engraving that was of this quality from the start. So accordingly, the engraving model itself also turned out fire. Now the task is, damn it, to start up again. I hope the power doesn't go out. To start the equipment, to get into the engraving process itself. Let's show how it's done. So we start the machine, start the chiller. Here we launch EasyCAD. At the same time, we connect here. Disconnect, connect. Connecting to the equipment, setting the necessary engraving parameters. There, and now I'll load some layout. I'll do some test engravings on these little tokens. By the way, it's also interesting to test what happens to this HDD disk. So I'll test the small tokens, and if anyone's interested, just ask or request them when you're getting consumables. So I can include these blanks with your supplies for you to feel them, look at them, and test what they're like. Let's do a live test. We have a layout, a template. I'll engrave 2 items at once, no less. I don't see the point otherwise. Now we'll adjust the parameters a bit. I'm not happy with the dimensions. Igor provided these plates. By the way, the plates are springy, made of stainless steel. Which grade, I have no idea. Well, basically, we'll just lay them out 2 at a time and just engrave them. So we have a height of 30, let's make it 40. Apply, and we'll redo the fill itself. As they say, here we go, 40 by 64 and a half. During the engraving, by the way, a mistake, stop. A mistake because the checkbox for the selected value wasn't checked. Once more, 40 by 64 and a half. Essentially, we have, roughly speaking, 1.5 tokens in terms of size and volume. How quickly it gets done will be clear in a moment. And as for the color rendering, we can't see it right now. We don't have the right angle, basically. I need to change the angle a bit, then you'll see how it looks. So the total time is 37 seconds. We did it on 2 plates at the same time, making sure to keep everything consistent between both. Again, if you look at it visually, you can really see how the process unfolds on each plate, side by side, which helps to compare the results more clearly. We hardly damaged the plate, but the result is, of course, amazing. It shimmers beautifully. Now, I'll make more of these plates, and so for anyone who wants to feel them, see them, so I'm not just sending plates for no reason, you can order consumables. I'll just toss them in with those supplies, but I'd strongly ask you to let me know in advance if you need such a test plate with this kind of engraving.